All right, so on to the final part of our review session, which is this last problem, which was the problem on my exam. Okay, so this is a pretty involved question. Let's buckle in for the ride. All right, let's begin. So, a hockey puck having a mass of 0.3 kilograms slides on the horizontal frictionless surface of an ice rink. Is the frictionless we like because it's frictionless, right? There's no friction, force of friction to consider. Let's highlight all the essential information. 0.3, what the? 0.3 kilograms. Frictionless. Friction. Two forces are acting on the puck as shown in the figure. The force one has a magnitude of 5 newtons, and force two has a magnitude of 8 newtons. Determine both the magnitude and direction of the puck's acceleration. All right, kind of complex. I want you to kind of zoom out and think about what's happening here. We have one force, we have a second force. What does this look like? This looks a lot like our airplane problem from like 2 videos ago, right? And this is where we have different axes that we have to consider. But think about it, they're asking us for acceleration. That means we have a force and a force. We need to put it together to make a third force. And that is the acceleration we need to find, okay? So I want you to get on the back of your head because it kind of builds a roadmap for you to begin thinking about this, where you need to go next, what you need to do first, what you need to do second, et cetera, et cetera. All right, enough yapping. Let's kind of break this down. So what I'm going to do is I'm going to break it down to two forces, right? Because we talked about force one, force two. So force two, so bear with me, I'm trying to figure out two. Oh, force two, we know is 8 newtons. Let's think about it, right? Force two is 8 newtons. Right here, we see that it is 8 newtons at an angle. 60 degrees, 8 newtons. Okay. So there should be a dashed line right here. Okay, there should be a dashed line. So we see force one. It's been doing that a lot lately. What in the world? Force one is equal to 5 newtons. What we see is we see x, we see the actual, and then we see this. We need to do that. 20 degrees angle right here. Going to the force one is 5 newtons. That means 5 newtons is right here. So this is kind of our starting off point. We're sketching what we're seeing. So what I want you to do next is kind of break it down like we talked about before, right? Break it down, take everything from the east. I'm going to show you how I do that, okay? So I'm going to start with F2 because that's what we have first. F2, take it from the east. Take it from the east. All right, so I'm going to draw my axes right here. This is my east. We good, right? If this force is going this way, we good, right? Because this is from the east. Look at that, from the east. Perfect. That means, all that means is that our F2x, without even drawing a triangle, we know that our F2x is going to be a cosine theta. So it's going to be 8 cosine 60. We know that our F2y is going to be using sine. Give me a second, I need to save this file. Okay, so our F2y is going to be something related to sine. Sine 60, using this law, this hypotenuse side right here, and using this angle, okay? Same thing, I want you to do the same thing for F1. Now this one's a little bit more complicated. It's not from the east. We have to make it from the east, right? They're telling us that this is the angle that it's at, 20 degrees. Does this look from the east to you? No. You need to take it from the east, which means that you need to start here, drag your pencil until it runs into this line and stop. I want you to think about a circle. Circle, 2 pi, 360 degrees, a full revolution, right? So that means if we want to find this little magical blue angle that's looking at us, we got to do 360 minus 20. So that would give us, let me breathe, 340 degrees. But we're not using 20 degrees, we're using 340 because that is the angle from the east axis. That guarantees that we can use F1x is equal to, what is this, 5 newtons? 5 cosine 340. And then F1y is equal to 5 cosine, sine 340. Let me tell you, you don't have to worry about negative, positive. This will make sure you end up where you need to end up, okay? So what did we do before? Last time when I came to this kind of problem, I told you to make an ultimate triangle, an ultimate pizza, right? Okay, let me think about how I broke this down. Sorry guys, this is a complicated problem. Give me a second. Yeah, I don't really agree with their method. Okay, so I'm gonna go solve this. I'm doing it on my own, okay? So we're gonna take this information. I'm gonna highlight all the x's in blue. I'm gonna highlight all the y components in green. Okay. And now I'm gonna create our ultimate triangle. Remember, our ultimate triangle is just any triangle. We just really want to make sure we have an x and a y to work off of and this angle that we can think about, okay? So we know that this is the force we're trying to find. This force is what we're going to use to find the acceleration, right? But in order to do that, we had to find out what the force is. Find out what the force is. We had to think about the sum, the sum of F1, F2. So this is like ultimate triangle. So that means this is going to be Fx, 1x plus F2x. This is going to be F1y plus F2y. So this is going to be, this is going to be this, okay? That's where I'm getting the numbers. I want y'all to see where I'm getting it from. Like I'm not pulling it from thin air. It's coming from someplace. Oh my gosh, 8 cosine 60 plus 5 sine 340. What just happened? Thank you for saving it. Thank you for saving it so much. 340. And this is going to be equal to, oh, I messed up. 5 cosine 340. And she can share about 8.7, okay? And this is basically what we're doing. Force, we're basically finding the sum of forces in the x direction. Isn't that crazy? Same here. For here, okay? You do 8 sine 60 plus 5 sine 340. This is going to get you sum of Fy, force in the y direction is equal to 5.2 newtons, okay? Crazy, right? So I hope it makes sense. I hope that based off of what we've been doing, this makes sense. So all we gotta do to find that big force, we gotta find the resultant, right? So that means we got to use Pythagorean. So any of these two can be A or B plus 8.7 squared is equal to C square root of that, okay? So that should get you, I don't think I actually did this. So now I've solved it before, but I solved it using a different method. So give me a second, I'm gonna plug this into a calculator. That's why I like to have everything solved out so I don't just sit around doing this. Okay, C should be equal to, I mean, basically C is equal to F, right? F should be equal to 10.1. Okay, now check yourself. Does that make logical sense? Is it greater? The hypotenuse is the longest side. Is it greater than the sum of the two? Yes, so we good. We balling? and we can kind of continue. So let's answer the question at hand, which is what is the acceleration? So we know that acceleration is equal to force is equal to ma, okay? So I have a force of 10.14 newtons. I think about the mass of the hockey puck itself, which they gave us 0.3, and times acceleration. All I gotta do now is solve for acceleration. 5.3. I'm gonna get an acceleration of 33.8 meters per second squared. Okay. Or 34 meters per second squared. That is my final answer. So I hope that makes sense. There's multiple ways you can solve this problem. One thing you could do is that you could do this crazy little triangle, and you could actually find the acceleration for each, and you can make an acceleration triangle. But I think this forces way is a little bit easier, it's simpler to do. I previously taught it to my students using the acceleration method, and it was confusing as fudge brownies, okay? And so I hope this way is much more clear, and I wish I'd done it to them before. Regret. But we're not done yet. Okay, we're not done yet. We have acceleration, which is the magnitude, but we need the direction of this puck. And so we need direction. But I told you already, direction, we ball in, it's easy, okay? Actually, is it easy? Let me see. Let me figure this out. I don't think it's easy. Oh, fudge. Might have lied to y'all a little bit. There might have been a reason, a logic to the madness, what I did before. Nah, there's no logic. I was just stupid before there. That's just the truth. Remember, to find the angle, all we gotta do is inverse tangent of opposite over adjacent, aka y over x of our ultimate triangle. So we do that, inverse tangent of Fy is 5.2 over 8.7. Let me go label it so that y'all can see it. I really want y'all to see where I'm getting these numbers from. Like, that's so important to me because I feel like that's the most confusing part, is figure out where all this calamity sums up. Okay. And if you plug that into your calculator, you should get about like 30.87 degrees. So something around there. And so the final answer will ultimately be 33.8 meters per second squared at 30.87 degrees. And that is your direction, and we are done. Praise the Lord. Okay, and so that is some of our review session for today. I hope that was very helpful. Y'all just text me if y'all have problems, so if y'all run into any issues. But ultimately, at the end of the day, in order to get good at this, you have to practice. You have to run into issues. You have to figure out what you're struggling with, okay? And so I hope this was very helpful. I hope that when you're reviewing this, it's helpful to see and work through my work. Hopefully all the color coding makes sense. And I'll set up these annotated slides. Y'all have a good night, okay? Let me end this meeting before it gets awkward.